Okay, so welcome back, and we're about to do our second vertical motion example here. So in the previous example, we had a ball, someone dropped from a bridge, and so their initial velocity was equal to zero. But obviously, we can give an object an initial velocity, and like this. So someone's throwing a ball upwards at 15 meters per second, calculates initial velocity. So they've just given it to us there. So u is equal to 15 meters per second upwards. And I guess I haven't actually defined what the positive one was, but we just kind of wrote it down. So we'll say up is positive. That's the first thing I should have done, wasn't it? Up is positive. So the velocity of the ball at the highest point of motion. So S, velocity of the ball at the highest point of motion. We don't actually know what S is equal to, so we'll write down SUVAT first. So we don't know what S is. We know that at its highest point, well, initially it was 15 meters per second. At its highest point, that's its maximum height. So when a ball gets to its highest point, it actually comes to a stop before it starts to descend. So for a moment, it stops, and so we can say that its velocity is 0 meters per second. Acceleration the whole way is going to be negative 9.81 meters per second. Remember the negative because it's downwards, and we don't know what the time is. Okay. So the velocity of the ball at the highest point of its motion. Okay, so let's have a look at our equations here. And we have to go back and have a look at what we actually have and what we're looking for. So we are looking for V, so velocity V. Oh, and I just said it was V. I don't know why we had so much space, but V equals 0 meters per second. Should have just wrote that down. I didn't read that properly, did I? But at least we've got our SUVAT written for the rest of them. The acceleration of the ball just after leaving the thrower's hand. Well, the acceleration is due to gravity, so it's a negative 9. So we can say A is equal to negative 9.81 meters per second squared. So negative 9.81 is, or you could say it's equal to 9.81 meters per second squared downwards as well. Because we've defined up as positive, if we have this negative sign, it implies that it's going down. So you don't always have to write it down. At the highest point, it still all stays the same. So A is equal to negative 9.81 meters per second squared. Okay. The maximum height reached. Okay, so now we actually want our SUVAT. And let's write them down again because we have the space. SUVAT. Let's just quickly write them down. We don't know what that is. U was equal to 15 meters per second up. V is equal to 0 meters per second. A is equal to negative 9.81 meters per second squared. And T we don't know. C we are not sure. So now we are looking for S because the maximum height is equal to the displacement from the thrower. So we know what V is, we know what U is, and we know what A is. So we're going to use this equation here on your formula sheet, the third equation, and we can write that on our document here. So V squared equals U squared plus 2AS. Now you can rearrange it now, or you can substitute the numbers in either way. So I'm going to substitute the numbers in first and then rearrange because some people like that better. 15 squared plus 2 times by 9 point, negative. That's a classic mistake that is made. You want negative 9.81. And then S, we don't know. So we've still got S there. Alright, so let's take away 15 squared from both sides. Negative 15 squared equals, and I'm going to just do this all in, I'll do it all in one step. I must be tired, I'm second guessing myself a little bit. 2 times 9.81, negative 9.81. So now we have to divide by 2 times negative 9.81. So our answer for S will be negative 15 squared divided by 2 outside of negative 9.81 is equal to S. And my maths isn't like conventions aren't very good. So S is going to be equals to, let's go negative 15, and we've got a little squared button there, divided by, I'm going to put in brackets, 2 times negative 9.81, and close bracket. So our total height is equal to 11.5. So yeah, 11.5 meters up. Okay. The time taken to reach the maximum height. Okay, so now we're looking for time, and we know all of the other variables now to get to that maximum height. So we can choose from a range of, we can either choose to have this one here, v equals u plus at, or we can choose this one here, s equals ut plus half at squared. And I'm going to go ahead and choose the v equals u plus at one over here because it's a bit simpler. Okay, so v equals u plus at. So that means that 0 is equal to 15 plus a minus or negative 9.81 times by t. So then we can subtract 15 from both sides and divide by negative 9.81. So that's 2 steps there, equals t. I hope that's not too quick. You do those both steps together. Therefore, t is equal to 15 divided by 9.81. When you know this, the minus signs cancel out, you don't have to put them in your calculator. 1.53. 1.53 seconds. Okay. And the velocity of the ball as it is caught by the thrower again. So you can go through all the Suvat problems again from the maximum height downwards, but we know from some of our points earlier that we scroll back up, an object at the top of its flight has a velocity of 0, and similarly an object dropped has an initial velocity of 0. That's not what I wanted. Vertical motion is said to be symmetrical. That is, the upward motion has the same speed, acceleration, and time characteristics as the downward motion, but in the opposite direction. So if our initial velocity was 15 meters per second, up, our v at the bottom, so this is after it's gone through the whole thing, is going to be negative 15 meters per second, which is equal to 15 meters per second downwards. Okay, so projectile motion is next.